Hello there, 11th graders. This is Teacher Krishna, and welcome to our physics class for week number 15. One more time, thank you for coming, and of course, thank you for completing all of the assignments that you have had so far. Before we start, just like always, log into Agilix, enter the Google Classroom, download your Word document, and save it in your physics folder. Of course, you have to name your file as it is specified right below. As we move, remember to take notes on the Word document. That is extremely necessary so you keep track of the most important things from this video and presentation. It's always important to start with the end in mind, so for topic 6.02 this week, the end in mind is the following. Describe the properties and characteristics of waves to apply their knowledge in realistic studies of the appearing waves in Earth. Okay, so the topic today is very interesting, and it is exploring waves. So let's start up. The sound from the radio and the waves in the ocean. So waves are things that you can find absolutely every single where around you. And if you listen to the radio, if you listen to music, if you watch TV, there are waves traveling around that are not perceptible by your naked eyes. But thanks to several studies, we have found that they exist. And there are other ones that are a little bit more observable, such as the ocean waves. And like if you go to Champerico here in Guatemala, you are able to see that several waves are coming to the beach. There are different types of waves. The kinetic energy from the wind causes water to move. Yeah, so those are just two examples. The waves from the television, the waves from the audio, and of course the waves from the ocean. But there are a lot of waves around. We're going to study some of them later on. And by basically the principle that waves follow is that vibration causes more vibration. So specifically, there is a stimulus that is going to cause a vibration to start. So there is one particle that will start vibrating, and since this particle is in contact with other particles, the vibration is going to be a trespass through each one of them. One example that I can give you right now is that you are listening to this video, and the speakers from your computer are generating vibration that is going to affect the air. So when air starts vibrating, it transmits sound. So that is why it is possible that you are listening to me right now, thanks to the vibration in the air particles and the speakers that cause the audio in your computers. Some waves are easy to see and some others are not. Just like I mentioned before, if you go to any beach around the world, you can see waves that are coming to the beach. But there are a lot of waves around you that you are not capable of observing, such as the sound waves or even light waves. And what is a wave? Basically, disturbances in particles that follow a chain effect. Just like I mentioned before, particles start vibrating and they are going to trespass all of that motion from one to another. It needs a medium through which to travel or propagate. Well, there are certain waves that actually need a medium to propagate. So if we talk about the waves that are caused by the ocean in the water, so basically the water is the medium where all of the vibration of the particles is being transferred to. If we mention a sound, it needs air in order to propagate. So let's imagine that you go to space. You want to be able to listen to anything in there because sound will not have air as the medium in order to travel. But there are other waves that do not need a medium in order to travel. Okay, we have another important term which is pulse, which is only one disturbance. So only one movement in the medium and then it goes back to its rest position. That's what we know in physics as pulse. We also have equilibrium, which is the resting position or like the original position of the medium you are studying. You have to notice that, oh, I'm sorry, sometimes some heavy transportation pass by. Let's continue. So basically, all waves transport energy. So the motion of particles actually is energy. Notice that all particles are always in movement. So, for example, right now, even though, let's analyze the particles from your cell phone. You might see that your cell phone is in a resting position right now, and probably to your eyes it is not moving, but in reality it is moving. All of the particles that it contains are moving. The difference is that sometimes they move slowly and other times they move faster. And usually particles are going to start moving faster when they acquire more energy. And how do we translate that to something that we can perceive as something simpler? Well, when you acquire more energy, you acquire more heat energy, or things get hotter. And the same thing happens in the vibrations of the waves. You have a lot of energy in one particle, it starts moving a lot, and basically it like sort of contagious more particles around it. And here is one example of what a wave looks like. So we have a tree, we have a jumping rope, and of course we have a kid that is oscillating the jumping rope up and down. So this motion that you can see right here from up and down are basically waves. Of course, one more time, this is a very visible wave that you can observe when altering the medium, which is a jumping rope. But there are some others, such as light and sound, that are more difficult to perceive. We have types of waves. And the first one is electromagnetic waves. A medium is not required. Remember, a medium is what the waves use in order to travel around. But there are certain waves that can travel even through millions of light years in space that do not require a medium. Of course, I am talking about sunlight or the light that is produced in waves. Just like I mentioned before, in outer space, there are not mediums that will allow several waves to travel. And when in outer space there is matter almost unexistent, we call it a vacuum. So electromagnetic waves are capable of traveling through vacuum, which is a place that has no matter or no medium, which is pretty interesting. And we have mechanical waves. A medium is required, such as the waves from the ocean or such as sound in air. We have transverse wave. So the particles move in a perpendicular direction to the motion of the wave. I know this might be a little bit difficult to understand it just by the concept, but I will show you a picture later on. And also we have longitudinal wave, in which particles of the matter move in the direction parallel to the motion of the wave. Okay, and basically right here are the two waves we were talking about. So notice, in the longitudinal wave, let's say it in simpler words, the energy is moving in the same direction of the wave. So if it is moving forth, all of the energy is moving forth. Or if it's coming back, all of the energy in the direction is coming back. Okay. But if we analyze transverse wave, you can notice that it is different from the longitudinal wave. The first difference that we can find is that usually longitudinal waves are smaller, or they have a smaller wavelength, and they are way more constant. Now in transverse wave, they are a little bit bigger, or they have a higher wavelength, and of course they have a smaller period of time. And just like it was mentioned, it acts perpendicularly to the direction of the motion. So let's suppose that the motion is going forward. So when we talk about a transverse movement, basically it means that the motion is going to act up and down. So remember, one more time, the direction of the force is going forward, but the wave is acting up and down. In the topic in Agilex, there are very nice videos and experiments that you can click on in order to have a better idea of both of these waves. So I recommend that you go to Agilex right after this video, and you can click on the videos that you have right there in order to have another explanation for this. Now we're going to analyze the wave parts. We have the equilibrium, the point around which waves oscillate. So we have like a line that goes right in the middle of the highest point of the wave and the lowest point of the wave. So that line that you can see right in the middle is what we call equilibrium. We have wavelength, which is the measure of a complete wave. We are going to analyze the parts, but later on you will find that waves have the crest at the top. So you have to measure the wavelength from one of the crests to another. We have the amplitude, which is the maximum a wave can oscillate from its equilibrium point. Remember I mentioned that there is like an invisible line that surpasses right of the middle in the wave. And from that middle point to the highest point above or the lowest point below is what we call amplitude. We have frequency, how many oscillations a wave completes in a period of time. If we go back to the example I gave you before, in transverse waves, you will notice that it will have a higher frequency than in the other ones because you have way more oscillations. And here we have a formula for the time in a wave, which is 1 divided by the frequency. And curious facts, the unit for the time will be second per wave. Now, question for you. What is the formula for the velocity of the wave? Explore and find out in page number 2. Explore wavelength. So go to this section in page number 2 of the Agilex lesson. Look for the velocity, for the formula for velocity, and attach it to your summary. And right here we have a picture that has all of the parts in the wave. So right here, first of all, let's analyze the crest of the wave. Just like I mentioned, is the highest point that you can reach at a wave, and that is right in the middle in between one and another. So, in order to measure the wavelength, you have to take two crests from the wave and measure the distance from one to another. Okay, that is the first part. Then we have the amplitude, and right here in the amplitude you can see that there is an arrow that goes from the equilibrium point or the equilibrium line to the crest. So basically that distance that exists from the equilibrium point to the crest, it's called a amplitude. Then notice that if we are talking about the highest point of the wave, it's the crest. Then if we're talking about the lowest part of the wave, we call it a trough. Okay. Let's continue. Now we have some modifications. So we have refraction, and waves expand their wavelength, or they are pushed apart. We have compression, where waves reduce their wavelength, or they are pushed together. And right here you have an image that represents both of them. So notice that in refractions, the waves are pushed apart, so their wavelength increases. And in the compression, all of the waves are pushed together, so their wavelength is reduced. All right, now we're going to jump with an exercise. So complete the recap section in page number 3, so you can review all of the concepts that I have mentioned here in the presentation. And read page number 4 and summarize it in your Word document. Once you are done with that, we're going to jump to the evaluation. And this is a little bit extensive, and you can find it in the last page of the topic. But first, you need to go to the Exploring Waves discussion and post an answer to this question. Waves are used in many practical applications to support work, entertainment, and health. One example is to use the ultrasound imaging to safely track the development of a growing fetus. What is a specific example of a practical application of waves in medicine, entertainment, safety, or other fields? Provide a brief explanation of how the properties of waves are used to that application. So trust me that what you can investigate is gigantic. Waves are used every single where around you. You can include examples related to medicine, to entertainment, so on and so forth. Right now, at the top of my mind, I can give you a clear example from IRTRA. If you have gone to, how do you call this place, Chocomilk, you will find that there is like an artificial beach where waves are produced. So basically, the owners of this place developed this system in which they apply a certain force to the water in order to create waves. So that is why it is possible for people to go there and have a great time with their family. But of course, you can look for way more applications. So do some research on the application of waves. Explain your answer in the discussion, and then we're going to move on with the next part. In your explanation, make sure you use at least 4 of the terms about waves introduced in this lesson. So, for example, with waves in Chocomilk, I can tell you that not all of them have the same frequency because usually the owners activate the waves for a little while and then it stops. So basically this changing in the periods of the waves can be an application of the terms that we studied. But of course you need to use 4 of them. Respond to at least one other person and explain why you agree or disagree with their comment. Okay? So it's very important that you post your comments earlier because I will be your classmates need something to comment on. So make sure to do it as soon as possible. When you finish, make a copy of your discussion posts and response and paste these items into a 6.02 Exploring Waves discussion assessment. And that is the evaluation for this week. So thank you guys for coming. Any questions? I am available in Google Classroom or in WhatsApp. I will be seeing you next week. Goodbye.